Good morning. Well, thank you for your participation this morning, and a huge thanks to the University of Utah for hosting this joint meeting. So my name is Rasoul Sorkhabi. I am a research professor at the University of Utah's EGI. I have been with the university for the past 22 years. Now, those of you who do not know about EGI, as my EGI director, Dr. Milin Dev, mentioned, actually EGI started in 1972 during the first oil shock. So we have been around for 52 years, continuous research and service to science and industry, so, and we are very, very proud of that. Next, please. Now, yes. Now, the focus of my presentation is on oil and gas, and I will share with you some of the activities and the directions we are taking in this space. We don't think that oil and gas is going to go away. Actually, I was talking to Christine Economides this morning. Last time I saw her and her late husband, Michael, was at a SPE meeting, and then she was just remarking that were Michael were here today, he would say that, you know, no exploration, no workforce training in oil and gas, then oil and gas prices will really go high. And I think I would agree with that. Now, where we are located, those of you who are geologists or know something about the geology of Utah know that even though we may not be producing 45% of, you know, oil production in the U.S. As Texas does, but we have some of the best geological setting in the world, I would say. Salt Lake itself is a tectonic valley. It's part of the Basin Range extensional province, but we also have access to other tectonic slides, including high plateaus, Colorado Plateau, and also the Rocky Mountains, foreland basins, you name it. I guess except for the ultra deep water, we have almost every analog of any, you know, petroleum system and reservoir scale analogs in Utah. That's the building of EGI. As Billy mentioned, we are a mid-sized, I would say, research institute with dozens of researchers from different backgrounds, engineers as well as geoscientists. So there's a good synergy between the two groups, especially under Milin's leadership. And depending on the project, we collaborate with one another. Now, one of the cornerstones of EGI is the Corporate Associate Program. It's an annual subscription, mainly oil and gas companies. So we have some benefits package for the CAs or corporate associates. EGI Connect is one of them. That's a global database online. That comes part of the membership. We also have other benefits for our members. And lastly, as Milin mentioned, the iCords, which is a global offshore database. It's also part of the membership. So EGI Connect has its own website. You know, the companies can go and see our reports. We have almost 1,000 EGI reports plus thousands of other documents, well logs and seismic lines. And every 2 years or so, we add to this portfolio. For example, since the COVID, over the past 4 years or so, we have added 40 major reports to our EGI Connect portfolio. Now, iCords is a web-based global database, mostly on petroleum basins. I have a brief video clip, if we can play it, if possible. this will save me lots of time in terms of...
This is an introduction to iCords Offshore, the integrated continent ocean research data system for offshore basins produced at the University of Utah's Energy and Geoscience Institute. The iCords program began at EGI with the realization that big data is the lifeblood of modern petroleum, geoscience, and technology. iCords is a multidisciplinary initiative to digitize and integrate geoscience data in a user-friendly platform for the benefit of energy companies. It is a web-based databank offered at an annual subscription to our clients. iCords has adopted a rigorous workflow for its database construction that includes deep data mining, quality control, and integration with digital systems that enables the user easy access, custom queries, and data analytics. iCords data comes from EGI's more than 5 decades of legacy data, as well as many other sources including International Ocean Discovery Program, formerly DSDP-ODP, NOAA's National Geophysical Data Center, U.S. Geological Survey, U.S. Bureau of Ocean Energy Management, as well as data services and survey institutions from Canada, Australia, UK, Norway, the Netherlands, and several other countries. iCords Offshore incorporates a large set of data types and services, including nearly 23 million geoscientific data from rock samples, cores, and cuttings from thousands of wells. The data can be queried and filtered under various categories, such as well header, sample information, stratigraphic age and rock type, total organic carbon, pyrolysis, thermal maturity, petrophysical properties, sonic velocity, and gas compositional analysis. The data can be accessed from the built-in interactive map, or by applying one or more filters to return a data table. There are also built-in analytic tools to view and interpret the geochemical data, which can also be exported as JPG or XLSX files. We continuously update our data bank and strive to incorporate new data from various sources for our clients. In addition to geologic and geochemical data, iCords Offshore also offers access to thousands of seismic lines from around the world. There are also supportive data maps such as heat flow and ocean floor age, to place the geochemical data in a regional context. iCords is an easy-to-use databank and research tool at your fingertips for subsurface energy industries. Exploration geoscientists will find iCords Offshore useful and easy to use. You can query and extract the geological, geochemical, and petrophysical data on specific wells or basins. You can plot and create figures for presentations and discussions. You can also upload your own data to augment the iCords data and use our built-in graphics to plot and export data and figures. The databank and graphic tools in iCords help exploration geoscientists compare and correlate wells and gain valuable insights into petroleum source and reservoir rocks in a given basin. iCords research work and database construction is conducted by a team of EGI scientists and IT experts who collectively have over 100 years of experience in geoscience and petroleum research or information technology. iCords Offshore is a web-based databank offered at an annual subscription to our clients. Your annual membership delivers analytics-ready geoscience data on a unified platform for data discovery, transformation, on-demand visualization, and integration. For more information, you can send us messages via the contact form on iCords Offshore website, icordsgeo.org, or direct email to the principal investigator. You may also visit EGI's website, egi.utah.edu.
Thank you. Now we can switch back to the PowerPoint file if possible. Okay, even though I'm talking on behalf of iCords, but this has been really a team effort, and I have listed some of the contributors and researchers, as well as IT experts working on iCords. Okay, I can skip these slides. Now, one of the, moving to, switching to specific projects. One of the projects which we have recently completed is the Guyana-Suriname Basins project. As you know, this basin has been very prolific in the past 10 years or so. Actually, outside of shale, this is the most, I would say, in terms of reserve growth, the best basin in the world. So if you are interested in, this report is ready to go, basically. It's, so if any of the company is interested in evaluating this and purchasing it, please contact us. Most of the wells which we analyzed were pre-Lisa. As you know, Lisa discovery really was the game changer in the Guyana-Suriname Basin. So most of the wells which we analyzed, the data come from pre-Lisa wells, which are really hard to find. We are developing a new research consortium on ultra-deep water plays, especially in the southern Atlantic margin as well as the equatorial Atlantic margin. Really, the motivation for this, as some of you may know, is the discovery of major, giant fields sitting on transitional crusts, which in the past were conceived as unproductive and almost infertile to petroleum systems. So we are trying to work out the crustal architecture of this place and then relate the basin evolution to petroleum systems in terms of source, charge, and accumulation. Next month, in November, one of our member companies will be hosting a meeting related to this consortium. So if you are interested, please contact me, and then I will give you more information. In the interest of time, I will skip this slide. Basically, as I mentioned, we are trying to pinpoint the source to accumulation pathways in ultra-deep water plays. Now, another space we have been working is, of course, shale. Millen and his students have done lots of work on shale in terms of reservoir characterization. We have a poster today. I don't know where the posters are, but wherever they are, my colleague, Dr. Palash Panja, will be there, and then he can answer all your questions. So what we have tried to do is to create an app called Shale Smart, EGI Shale Smart, and we have data, production data, and some geological data on almost 100,000 horizontal wells from almost a dozen shale tight plays in the US. And what we are trying to do is reverse engineering of production data to petroleum systems. And we have developed a key performance indicator called MPI, Normalized Production Index. The unit is, standard tank barrel per foot per month. Then you can analyze and screen the performance of each well. Also, we have calculated EUR based on declining curves and to some extent machine learning. Now, we are trying to use this database to study some of the re-stimulation projects that are going on. As you know, re-stimulation is really the name of the game now in shale. Already more than 300 wells have been re-stimulated in Eagle Ford play only. So we are trying to do some numerical simulation of some important problems based on real data, both production as well as geology. So this database is helpful for candidate selection of those wells which are supposed to be or are planned to be re-stimulated. We have published a large number of papers, and our work has been featured in the APG Explorer and other media. So if you are interested in bibliography of our publication, again, please contact Palash or myself or Dr. Deb, and we will send you our publications. Again, I will skip this. This is the workflow. We are trying to add machine learning component to shale characterization. And also we have, we are creating a geological database on almost more than 20,000 wells related to source rocks in the US only. So this is also going to be a huge component of Shale Smart. Now, coming back to our own backyard in Utah, Colorado Plateau, even though it's called Colorado Plateau, but most of the plateau actually is situated in Utah and not in Colorado. So that is where the old or the traditional energy corridor is. Almost all of our oil and gas fields and wells are located on the high plateaus. But the new energy corridor is really being developed in the Great Basin. So we published I would say, popular article about Utah's new energy corridor. It came out actually this month in First Break, publication of the EAGE in Europe. So within a distance of 160 miles or so, you have geothermal fields, solar, wind, hydrogen storage. I do not know of any other place that you would have all these energy transition technologies concentrated in such a small space. For the traditional energy corridor, we are trying to develop what's called the energy superbasin model, an integrated co-production of oil and gas together with other resources, as well as carbon capture. So that's something that EGI is also working on. I think this is my last slide. Thank you very much for your patience and attention. And you can also visit our website for more information. Thank you.